All right, let's take a look at making predictions for using our equation of best fit. So very similar directions to our last video, 9.1, where we found the equation of best fit using Desmos. Now we're going to take these equations and we are going to, or these data, and we're actually going to solve, we're going to find like future data from it. So the one thing I didn't cover in the last video is what happens when we're talking about years. Now those numbers are pretty big. So when we're talking about years, like in the model here, the table below shows the number of additions from the lead role each year since 2004. 2004 is actually going to be represented as our start year. So that's actually going to be 0. And 2005 is 1 year after that. 2006 is 2 years after, 3 years, 4 years, 5 years, 6 years. We need to find out what 2013 is, so that's year 7. 2012 is year 8. 2013 is year 9. So that's what we're going to be looking for in the end. That is not our answer. Keep that in mind. We are going to use Desmos now, but we're going to, instead of using the year, we're going to use the number like from start and how many years since. So let's look at what we get. Let's go back to Desmos, and I'll retype everything in just so you can see exactly what we do. So we go to the plus table, and let's type it in. We got 0, 1, 2, 3, 4, 5, 6, 7. Make sure I'm right there. 7? Oh no, just 6. Oh no, what? Oh yeah, no, just 6. Don't have more than, if you have more than you need, then it's not good for the data. 21, 23, 26, 34, 38, 39, 41. All right, we need to figure out which model this would be best fitting or fit. Is it a linear model? So we have y1, get the little squiggly. So then we can say, hey, I want to see which one's better. X sub 1 plus b. There we go, we get an r squared. Now we have y sub 2, or y1 again. And we have ax1 squared plus bx1 plus c. All right, let's take a look at our r squared values. We have linear is 0.9481. That's pretty close to 1. R squared on the quadratic is 0.95. That's bigger. So we're going to use quadratic. So I'm going to write down my a's is negative 0.21. B is 5, and the C is 19.5. All right, let's plug that in so we have, I'm just going to write it off to the side. We have y equals, the A is negative 0.21 x squared plus 5x, that's the B, plus C. And if you're like, wait a second, where is this coming from? This is coming from the equation y equals ax squared plus bx plus c. That is the general form of a quadratic equation, just in general, like without you plugging numbers in. Once we plug numbers in, now this quadratic is very specific to this problem. So now we are going to use that quadratic equation to actually find out how many people are auditioning in 2013. We're not going to use 2013. We're going to use 9 though. And when we substituted these numbers into Desmos, take a look at what column we did with what. The first column was their x, our second column was our y. So our first column over here is x, second column is y. So we're going to use for x, we're going to use 9. So when x equals 9, we are going to find it out. We're going to substitute that in. So negative 0.21 times 9 squared plus 5 times 9 plus 19.5. So we're going to do that in the calculator quick. Where's my calculator? And so we have negative 0.21 times 9 squared plus 5 times 9 plus 19.5. That's 47.49, 47.49, 47.49. So 47.49. That is going to be approximately just a little bit under 50. So we'll go with 47 auditions is the prediction. And this is actually how they use like predicting all kinds of future statistics using this type of thing. So we'll do more in class. We'll do all these in class. Just time-wise, I'll just do the one model for you. All right.